Welcome back to the channel. Today, we're taking a close look at one of the most extreme earth-moving machines still operating in the United States. The Komatsu D575A-3SR, widely recognized as the largest production bulldozer ever manufactured, but the model we're featuring today is not a standard factory-spec unit. This machine has undergone a full modernization program, upgrading everything from its blade and undercarriage to its cooling system, automation platform, and operator controls. The goal was simple: increase output while reducing fuel burn and wear. The result is measurable. Compared to a baseline D575A-3SR, this upgraded unit has documented an 18% increase in hourly material movement while cutting fuel consumption per cubic yard by just over 8%. These gains weren't achieved by one modification, but through a comprehensive upgrade package targeting performance, durability, and operational efficiency. Asterisk from the outside. The machine still carries the imposing physical presence of a D575A, standing roughly 24 feet tall at the exhaust stack, stretching over 38 feet from blade to ripper, and weighing more than 153 metric tons. It remains the heaviest production dozer ever put into commercial service, but a closer inspection of the blade reveals the first major improvement. The cutting edges and end bits have been replaced with ESCO all-cast, where components, these high-alloy castings provide over 30% more abrasion resistance than standard heat-treated steel. The center section is cast as a solid reinforced unit, reducing flex and absorbing high-impact loads. The corner end bits now extend deeper into the moldboard structure, preventing scalloping during repetitive floor cutting. Operators have reported nearly double the edge life before needing a changeout, especially in high silica, overburden conditions. Asterisk, moving to the rear. The signature component of the 3SR model, its single shank ripper, has also received performance upgrades. The standard ripper tooth has been replaced with a variable pitch hardened alloy boot, allowing the operator to select between three tooth geometries depending on ground hardness. In softer shale or weathered rock, a shallow entry angle allows faster ripping with less engine load. In compacted or frozen material, the pitch can be adjusted to a steeper profile, applying more downforce without overstressing the ripper linkage. Sensors mounted in the hydraulic cylinder transmit live pressure and temperature data to the operator display, helping prevent overload cycles. These improvements have resulted in an approximately 12% gain in ripping efficiency, while reducing wear on the shank assembly by nearly 30%. Asterisk, underneath the machine. The undercarriage, traditionally the highest cost wear component on heavy track dozers, has been rebuilt with premium Burco mining class hardware. All rollers, idlers, track chains, and bushings were replaced with sealed and lubricated extended life components. The 32-inch track shoes remain factory width, but the Grouser bars have been overlaid with chromium carbide, dramatically slowing wear in abrasive terrain. Based on current rock conditions at this mine site, projected undercarriage lifespan has increased from around 8,000 operating hours to between 10,000 and 12,000 hours before full chain replacement is required. That increase represents a maintenance cost avoidance of more than $200,000 over a 3-year period. Asterisk, where this machine truly moves into modern territory is in its automation capability. Twin GNSS receiver masts are mounted on the blade corners, paired with an inertial measurement module and tied into a Trimble Earthworks 3D machine control package. This system gives the dozer real-time awareness of grade design targets, automatically adjusting blade angle and lift to maintain the correct elevation without constant manual correction. In continuous slot dozing operations, this automation has reduced grade deviation to less than 0.3 inches, results that previously required a veteran operator working manually. Operational data from the mine's performance tracking team shows a 15% increase in cycle consistency and an 8% reduction in fuel used per bank cubic yard moved. Asterisk, a secondary electronic upgrade adds remote operation capability. Using an RCT, Control Master radio system, the dozer can be operated from up to 600 meters away with full control over steering, throttle, blade, and ripper. Multiple high-definition camera pods are mounted around the machine, sending live video back to an operator console located in a control trailer. This feature is primarily used when working near unstable high walls or in areas where gas exposure risk is elevated. Instead of halting production, the machine continues working under remote control, allowing productivity to continue while reducing operator exposure. Over the last 6 months, safety-related downtime has been reduced by nearly 5% due to this upgrade alone. To maintain performance under sustained heavy load, the factory cooling system has been replaced with a Masabi modular radiator and aftercooler setup. Unlike standard core assemblies, Masabi designs use individual cooling tubes that flex independently under vibration and can be replaced without removing the entire unit. Paired with dual variable speed hydraulic cooling fans, the engine temperature is kept 8 to 10 degrees cooler at 75% load in 90-degree ambient conditions. This prevents the automatic power derating that often occurs in summer operations. When the engine isn't under full load, the fans slow down, saving horsepower. Logged performance data shows fuel savings of approximately 2.1 gallons per hour, attributed solely to intelligent cooling control. Hydraulic performance has also been refined. The implement pump has been recalibrated for faster response without exceeding pressure limits. Relief valves were replaced with temperature-stable assemblies, and the return side filtration system was upgraded with dual high-efficiency filters. New contamination sensors monitor hydraulic fluid clarity in real time, triggering alerts if abrasive material enters the circuit. These improvements have increased control smoothness while extending component life. Blade, lift, and tilt motions register more precisely, especially when paired with the machine control system, which relies on consistent hydraulic response to maintain accurate grading. Inside the cab, the objective was not luxury, but operator focus and fatigue reduction. The standard suspension seat was replaced with a low-frequency isolation seat designed for high-vibration environments. A secondary monitor was added to display machine control interface graphics, alongside standard engine and drivetrain readouts. Additional digital gauges were installed to display torque converter slip, hydraulic oil temperature delta, and alternator output. Sound insulation improvements have lowered in-cab decibel levels by nearly 4 dB at full engine load. LED lighting, mounted at the blade, cab roof, and ripper assembly, provides wider and brighter nighttime visibility with less amperage draw than halogen fixtures. Before any upgrades were implemented, the machine underwent full structural inspection. Frame rails, pivot pins, and bushings were scanned and measured. Push arms were magnaflux tested for equalizer bar movement was evaluated for wear. Only after confirming structural baseline health did the modification program begin. The complete upgrade package, including remote control hardware, machine control installation, undercarriage rebuild, cooling, retrofit, hydraulic upgrades, electrical expansion, and cab improvements totaled approximately $780,000 above typical operating maintenance. A used Komatsu D575A-3SR, in workable condition, typically trades between $1.40 and $1.8 million depending on hours. With these upgrades, the machine's output-to-cost ratio now exceeds that of dual D11R deployments in similar production roles. Internal cost per turn analysis from the operating mine calculated a full return on investment in just over 14 months. Based on component life projections, the machine is expected to operate for another 10,000 hours before requiring major lifecycle intervention. In the field, the difference is not louder sound or more aggressive blade behavior. The upgraded unit no longer loses power during extended uphill pushes due to heat derating. It no longer drifts when following long cut lines across uneven material. Blade edges stay sharper longer. Track pitch separation stays within tolerance well past 4,000 hours. Instead of relying purely on force, the machine now applies power with precision. The original D575A platform has always been known for overwhelming ground material through mass alone. This upgraded version pairs that mass with intelligent control. delivering production not just by size, but by efficiency. Asterisk. One of the most significant long-term advantages of these upgrades is that they make a 20-year-old mechanical platform compatible with modern fleet management tools. The GNSS and remote control systems allow integration with dispatch software. Operators can receive digital task assignments, track cycle data, and even remotely shut down the unit if thresholds are exceeded. Operational analytics can be streamed to cloud dashboards for maintenance planning and shift performance review. What was once a fully manual machine now reports data comparable to modern autonomous haul units. Asterisk, not replacement, but optimization, not just keeping old iron running, but elevating it to modern standards. When mass, precision, cooling efficiency, and digital control are combined, machines like the Komatsu D575A-3SR don't just stay relevant,